this, but you've heard about quantum entangled particles.
Yes.
Where I can create a pair of particles that know about one another, and now they're separated in space and in time. And if you observe that other particle, it instantly changes the state of the particle back, the other particle that's back where I am. And by the way, that they communicate instantaneously, faster than the speed of light.
When you say if you observe, do you mean that if you observe it with
anything, doesn't matter.
But you have to do something.
Yeah,
you have to
do. Yes.
So something has to interact with it. It's not woo.
No, it's not.
But
it is
people think,
not woo.
But you say that, people go, yeah, I saw that in The Secret.
Yeah. So the problem is the word observe. People think is a psychological thing, but in physics, it's got nothing to do with.
It's a measurement.
It's a measurement thing.
Right.
And so in other words, if there's an electron sitting in the middle of this table and all the lights are out, I can say, I think there's an electron here. Let me find out. And the moment I turn on the lights, the light interacts, a photon interacts with the electron and kicks it somewhere else. So the more I try to measure its position, the less I know its position.
Ooh.
So because the measurement requires an interaction with it. And in the quantum scale, interactions change the state of the experiment that you're conducting. We know this, we've quantified it, we don't like it, but we deal with it. And in the act of dealing with it, you can exploit that fact for other purposes. We exploit quantum craziness to birth the information technology revolution. There is no creation, storage, or retrieval of information without an exploitation of the quantum. So, and by the way, the quantum was discovered in quantum physics as a branch of physics was discovered in the 1920s. If you were around back then, and your tax buddies who don't like paying taxes, what would you have said? Why are you spending government money
on
the atom and on molecules? Like, you can't even see them. What good is it? I'm a woodworker. I just care about my wood atoms, right? Here I am. Shove that where your tax dollar is. And so it would look like you're wasting your own time and everybody else's money. It would take decades, 5 decades, 4 or 5 decades before we would realize what role that would play in computing, this creation, storage, and retrieval of information. And by some measures, it's 1/3 of the world's GDP is traceable to what quantum physics does for us on a computing scale. So anyone, yes. Well, I mean, there are ways to do it. There's certain industries that would still be there without computing, but they're made more efficient with it. Okay, so UPS tracks all of their trucks with GPS and with computing devices that invokes the quantum. But UPS predates the use of these tools. But you can look at profits relative to their efficiencies that are enabled by these technologies, as well as entire fields that didn't exist before computing. You add all that up, it's a stunning fact. And so my only point is that if you want today to say, why study this when we have these other problems? All I do is take you back to the cave and let's say, all right, we're in a cave. And there's a mountain over there in a valley. And I tell the tribe leaders, I want to explore that mountain and that valley. No, we can't afford to send you out there now. We have to solve the cave problems first before anyone leaves the cave. We laugh at that. That's an absurd claim to make in caveman days. I don't know if anyone did it, but that's a crazy thought because there are solutions to your problems that might exist and time has demonstrated likely exist by leaving the cave that you can then discover. So for me, exploration is not just space, all the frontiers of the unknown, biology, chemistry, AI, you know those frontiers. And then you can cross-pollinate them and transform civilization. And then